Assalamu alaikum, my dear student. Today we will talk about the linear differential equation and Bernoulis equation. In another way, we call it reducible equation, equation reducible to linear differential equation. So this type of linear differential equation is called Bernoulis equation. So we will talk about start from the linear differential equation. A differential equation is of the form when dy over dx plus p times of y, which is equals to q, this is called linear differential equation, where p and q are the functions of x but not y or any constant. So student, it means it has three steps. The first working step it is convert the given equation into linear. In the second step, find the integrating factor. Formula of integrating factor, which is equals to e raised to the power integral of p of dx. We will find them. Then after that, in the third step, we multiplying by the integrating factor of y, which is equals to integral q into I of f. I dot f represent here integrating factor into dx, and we integrate and find the solution. So we consider here, student, the differential equation. Solve the differential equation. Sine of x dy upon dx plus 2y, which is equals to 10 cube x upon 2. It means this is half integral, half angle formula. So it means 10 cube x upon 2. Now start from this. We find the solution, student. If any value multiply by, if any function multiply by dy over dx, according to dy over dx, it has no value. So we will multiply or divide by each term. It means so student, when we consider here, so it means this term multiplying by dy over dx, so it means we will divide the sine of x, the whole equation, in the first step. First we write the differential equation, sine x into dy upon dx plus 2y, which is equals to 10 cube x upon 2, whole equation divided by sine x means sine x upon sine x into dy upon dx plus 2 times y upon sine x, which is equals to 10 cube x upon 2 whole divided by sine x. They cancel each other. So dy upon dx plus 2 times of y upon sine x into, which is equals to 10 cube x upon 2 whole upon sine x. So first, in the first step, we find the solution. So this form, this is linear of dy upon dx plus p times of y is equals to q. If we consider this, if we write y upon sine x, so it means it is P of y. So if we write this equation, P of y means 2 upon sine x, and 2 upon sine x means 2 cosec x. 2 cosec x into y. This is called P, this is called y, is equals to q. It means this will be q. What is P? It means P is equals to 2 times cosec x. And what is q? So it means after that we will determine what is P and Q with the help of linear differential equation. So student, integrate, find the integrating factor, exponential P into dx. It means exponential 2 times cosec x into dx. So what is the integral, student? Cosec x. The integral of cosec x is 2 times of cosec x into dx raised to the power exponential. It is in this form, 2 outside the integral because it is constant. So the integral of cosec x is log 2 times log 10x upon 2. So it means, in another way, e to the power log 10x whole upon 2 they cancel each other. It means 10 square x upon 2. So this is called student integrating factor. We will find the integrating factor. After that, student, we will applying the second step. In the first step, we have find the convert the given equation into differential equation. In the second step, we find the integrating factor. In the third step, after finding the integrating factor, we multiplying by variable y, and the next step. So according to third step, y into I dot f, which is equals to I dot f into q of dx, q dx plus c. So student, y into integrating factor, it is 10 square x upon 2, which is equals to 10 square x upon 2 and what is q? Q is, this is q, so 10 cube x upon 2 sine x. So 10 cube x upon 2 sine x into dx, the sine integral plus c. So integrating factor, it is 10 square x upon 2. We will find this one in the previous step. What is q? Q is 10 cube x upon 2. In the we write only left hand side as it is. Student, as you know that, what is sin x? Sin x is equals to, since sin x is equals to 2 sin square x upon 2 cos square x upon 2, which is equals to this. Two sin x cos x upon 2. There is no squaring. So sin x is equals to 2 times sin x upon 2. We will convert it into full angle into half angle. So they are equal. So when we put here, student, so 10 10 square x by 2, 10 cube x upon 2 sine 2 times of sin x upon 2 cos x by 2 of dx plus c. So in the next step, student, y is equals y into 10 square x upon 2 . But this is equals to, when we integrate, student, the sign of integral after integration, student, it is 1 upon 2 the sign of integral tan 4x upon 2, because sin x upon 2 cos x upon 2 divided by this. If we put here, as you know that sin square tan square x upon 2, which is equals to sin x upon 2 sin square x upon 2 cos square x upon 2, as you know that. So it means the remaining term, it is tan 4x upon 2 and cos square x upon 2 into dx plus c. When we simplifying these two terms and find the result, so cos square x 1 upon cos square, it is sec square x. So tan 4 x upon 2 into sec square x upon 2 into dx, which is equals to 1 upon 2. If we suppose, student, let t is equals to, or u is equals to tan x upon 2, so du is equals to 1 upon 2 sec square x upon 2. It means the derivative of tan x is sec square x upon 2. So it means it is du 1 upon 2 multiplied by this. It means 1 upon 2 sec square x upon 2 and tan 4x upon 2. So that's, we will integrate 2 multiplied by du. So it means 2 du is equals to sec square x upon 2. So therefore 1 upon 2 u to the power 4 into 2 du plus c, the sign of integral y is equals to tan square x upon 2 as it is, u4, 2 divided by 2, it means u5 upon 5 plus c put by q, u is 10x by 2. So the answer it is 10 to the power 5x upon 2, 1 upon 5, and y is equal y into 10 square x upon 2 plus c. So student, this is called our solution of the differential equation. When we applying the condition, the given condition shows here linear differential equation. So now the next, equation reducible to the linear form. Bernoulis equation, it means in another way call it Bernoulis equation. If dy upon dx plus p of 5 is which is equals to q into y raised to the power n. This is called Bernoulis equation. It means given differential equation is not, it is in linear form. In another way, we convert it into linear equation, linear differential equation form. Like as this. For example, if we consider this, solve the differential equation x square into dy plus x into dy plus y into x plus y into dx, which is equals to 0. So first we write an equation. If whole equation multiplying by dx means x square into dy upon dx plus y into x plus y, which is equals to 0. And in the next step, student, if we divide it by x square, it means x square divided by x square into dy upon dx plus xy upon x square plus y square upon x square, which is equals to 0. X divided by x, so dy upon dx plus y upon x, and this value shift, it is on the right hand side, so y square upon x square. So if we remove the y square on the right hand side, this term, if we remove, so it means whole equation divided by y square only. So 1 upon y square into dy upon dx plus y upon y square into x, which is equals to minus y square upon y square into x square. So 1 upon y square into dy upon dx plus 1 upon y, it means xy, because y cancel with y, so the remaining term it is 1 upon xy, which is equals to minus 1 upon x. So if we check here, student, this is called dy upon dx plus py plus equals to q into y raised to the power n. So it means if the given equation is in this form, so we will convert it into this linear form. So this equation is called linear equation. So in the next step, student, when we put here z is equals to 1 over y, so that 1 upon y square into dy upon dx, which is equals to dz upon dx. So it means dy upon dx of 1 upon y square, which is equals to dz upon dx. So if we write the equation number 1, so 1 implies that dz upon dx plus 1 upon y is z, so it means 1 upon y is z, so z upon x, which is equals to student, when we consider here 1 upon y is z, so z over x equals to minus 1 upon x square as it is. So this equation will be in this form. So what is p? If we write here dz upon dx plus 1 upon x into z minus 1 upon x square, so this is called p. It means we write here pp is 1 upon x, and what is q? On the right hand side it is called q. So q is equals to minus 1 upon x square. So after that, we find the integrating factor. Integrating factor is equals to exponential minus 1 upon x into dx. So the integral is e raised to the power minus ln x, or if we write in this form ln of x minus 1, so it means exponential and ln both are cancel each other. So x inverse, or x inverse means the integrating factor it is 1 upon x. So and we find the integrating factor I dot f. After that, therefore z dot 1 upon x plus minus 1 upon x square into 1 upon x. It is q, it is p into dx. Then integrate, which is equals to according to linear differential equation. We consider here plus c. That means minus 1 upon x cube into dx plus c, and z is equals to 1 upon y, put back 1 upon y, 1 upon y multiplied by x, it is 1 upon xy, which is equals to the integral of this is minus 2 upon 2 minus sine plus c. So 1 upon xy is equals to minus plus 1 upon 2 x to the power minus 2 plus c, or if we write here 1 upon xy is equals to 1 upon 2 times of x square plus c. So This is the solution of differential equation. The student, here we consider the application equation reducible to the linear form. If you have the given differential equation, it is in this form. This form is called the Bernoulis equation. So we will convert it into linear differential equation and then find the result. Now the next application about this one, equation reducible to question number 2. So it means Bernoulis equations you have given. We will convert it into linear differential equation and find the solution. So dy over dx minus 10y over 1 plus x, student, which is equals to 1 plus x into exponential x sec y. Both are function x, but it is y, so we will remove it, and it means whole equation divided by multiplying by whole equation multiplying by cos y. So it means cos y into dy upon dx minus 10y upon cos y into 1 plus x, which is equals to 1 plus x into exponential of x sec y divided by cos y. It means they cancel each other, 1 upon cos and sec. So 1 upon cos will be cancel each other. So we do not write here. And when we solve it, 10 upon y, 10y is equals to cos sine upon cos and multiplying by cos. I have a mistake. Multiplying by cos y so it means cos y into sec y, they cancel each other because they are similar. And when we convert it into sine upon cos multiplied by cos y, it means it is sine y only. In the next step, tan y upon 1 plus x, because the whole equation multiplying by cos y, so the remaining term it is cos y into dy over dx minus sine of x sine of y whole upon 1 plus x, which is equals to 1 plus x into exponential x. So friend, first we will remove on the right hand side the variable y. So after that, friend, we put here sine y with this, let z is equals to sine y, so that if we find the derivative, so dz upon dx, which is equals to cos y into dy upon dx. So now I student write an equation number a, for example. So these values put in equation a implies that what is cos y? Cos y into dy over dx, which is equals to dz upon dx. So we write here dz upon dx is equals to, and sin y is z, so minus z upon 1 plus x minus sin not equal to, and which is equals to 1 plus x into exponential of x. Yes, the coefficient of z. What is the coefficient of z is equals to dz upon dx minus 1 upon 1 plus x of z equals to 1 plus x into exponential of x. So student, this is called P. What is P? P is equals to 1 upon 1 plus x. And what is Q? On the right hand side, this is called Q. So P and Q is friend, when we find, after that we find the integrating factor. Integrating factor it is equals to exponential P of dx, which is equals to exponential 1 upon 1 plus x of dx. So find the integral, because it is minus 1, so we write here minus sign, because it is total value, it is minus with minus. So it is minus ln 1 plus x. It means exponential ln 1 plus x whole power minus 1 according to log rule. They cancel each other, student, exponential and logarithmic. So 1 plus x whole power minus 1, which is equals to 1 upon 1 plus x. This is called integrating factor. After find the integrating factor, student, we are applying the linear differential equation form. So x dot integrating factor, it is 1 upon 1 plus x, which is equals to z into, sorry for that, it is z. So z dot 1 upon 1 plus x, it means z into 1 upon 1 plus x is called integrating factor. We find in the previous step, which is equals to double integral 1 plus x into exponential of x multiplying by the integrating factor 1 plus x into dx. That means they cancel each other, students. Plus c is a constant of integration. So exponential of x into dx plus c, the integral of exponential of x, it is exponential of x plus c. What is z? You know z, student? Z is equals to sin y. So put back z. So z is equals to sin y into 1 upon 1 plus x. So the answer it is sin y into 1 upon 1 plus x, which is equal to. So student, this is called differential equation. When we applying the condition, it is the given equation, it is in equation reducible to linear differential equation. So that type is called Bernoulis equation. So I have completed my topic. Student, I hope you will learn about the lecture today. So thank you very much. Take care. God bless you. Allah.